this video, we're going to take a look at machine learning, and we're going to use the example of the Titanic dataset. And in large part, we're going to implement some code in R suggested by Halvarian. You might take a look at a previous video clip here, Titanic tidyverse 5. It was just one of 5 videos where we took here at the end, after doing some tidyverse analysis, we set out how to approach the Titanic classification problem in terms of who survived and who perished. Again, in this video clip, we're going to follow suit, but we're going to use Google Collaboratory, which we'll open in a second, and just run through a set of techniques for implementing visualization of some of these techniques for machine learning that are, again, useful for addressing problems of classification. We'll explore the Google Collaboratory, and then we'll download the same code into RStudio and compare just quality of visualization. So double click here and we'll go in. And to run R in the Google Collaboratory, you need to put in this command, and thereafter you can put in R code so long as you have a prefix of the $% and R. We'll install the tidyverse suite. That can be quite fast. And we'll make available the library. So in there, we should have dplyr, we should have ggplot2, we should have tibble, tidyr, reader, forecast, stringer. Okay, but the main ones we'll use here, ggplot2, dplyr, for just a small amount of data manipulation. And Halvarian makes available the Titanic data in the Journal of Economic Perspectives if you follow the link, but you can directly put the Titanic data into your environment by installing this package PASWR that's available on CRAN. And again, by using library here, you invoke that, and the 1,309 passenger list is available. We can check to make sure that that data is available using this dplyr verb. And you can see here we have the 1,309 passengers, and we have 14 columns of data capturing information about each of the passengers, their passenger class, survived, name, so on. Okay, a little bit of dplyr just to see that everything is working well. Little bit of pivot tabling using a pipe operator where we classify the passengers into those who survived. So the bulk drowned, 0 denotes drowning, 1 denotes surviving. 500 out of the 1,309 survived. So it was a smaller group who actually survived. We set out to employ here a Logout model suggested by Halvarian in his paper. Again, just to draw our attention to the paper, it's a Journal of Economic Perspectives, and it's big data, new tricks for econometrics. And the data set and so on, the paper, you can download the paper there. But in the section related to the Titanic data set, he suggests we look at a Logout model to see if age is an important predictor in terms of those who survived. There was some preliminary evidence when we went through the tidyverse that those who were quite young had better prospects of surviving. Those who were a bit older, in their 20s, less so. And then there's a few cases we had seen a Python graph in the on the Vinegar Hill website. When we looked at visualizations for the Titanic, we had seen a number of graphs where survivorship, age and so on, but one of the final graphs if you run through here, we can see that for a particular age cohort, those less than 15, 16, they did better in terms of survival. So young people, very young people, children, were prioritized in terms of those who were put on the lifeboats. That's fairly clear. But when we run this Logout model, we don't directly observe here very strong relationship between age and survival, and it's barely statistically significant. In fact, at the 5% level, it's not statistically significant. So we could run another more elaborate Logout model. The p-class here is a factor, so it's broken up into dummies, 0, 1s, and we can see that the higher when we say higher class, third class is not survival, is negatively related to the class in terms of a third class. There's a stronger negative relationship with survival. It is statistically significant. Again, if you're male, it is statistically significant. Your chances of survival are poor. Age, the younger here would appear better your prospects. It is, in this instance, it is statistically significant, right? So when we consider the p-values and the t-stats, in this instance, when we incorporate more variables, we get a broader picture here. And age, there's a negative relationship between age and survival. In other words, the younger you are, the more likely it is you would survive. Now, again, we can see through the machine learning, through our part, we will see in a moment using different approaches, but when we set up a decision tree, which is powerful and a popular predictive machine learning technique, and we apply the code suggested by Halvarian, we can see how age has a non-linear effect. And again, we would get that from some of this machine learning. Okay, so the first thing we will do here is to employ, we will install our part and make it available. The R part is it's a library that is used for classification problems. We can grow a tree, and we can examine the effect of each of the variables in a non-linear fashion. This is a very powerful way of getting a sense of what's in the data. Tidyverse allows us to do deep exploratory analysis, but these decision trees are also very powerful visualization tools, and Halvarian suggests these approaches when we're dealing with econometric and statistical problems. Now here we've refactored survive to be no longer 1, 0 integer. If we go back to the survived, it was an integer. We're going to remove that now to a fact, create now, mutate it into a factor using the dplyr verb mutate. And you can see here survived is lived, right? So we've changed the 0 to died and 1 to lived. Okay, so it becomes, it's no longer, it's a factor, right? And then we'll splice out each of the, so titanic3 in this new data set, titanic5, we will create variable sex, age, p-class, survived, and sibling, spouse. And then we'll run our part where we just very simply use 2 variables to assist in terms of trying to figure out the relationship of did the passenger survive, and we're looking at class and age. So this is a very simple model, very parsimonious model. We'll prune it, okay? So again, running some optimization, again following Halvarian, or part model prune, and we have now generated a visualization, which is very useful, and it seems to tally a bit with the tidyverse exploratory data analysis. So what we might say, using fairly parsimonious type model, if the individual is in third class on the Titanic, we can see here they basically died, right? 528 out of 709 passengers would have died. If you were not third class, then you're either first class or second. And if your age was greater than 16, okay, let's go with the case where if your age is not greater than 16, right? So if you're not greater than 16, it means you're a child, so no. And again, keep in mind you are first and second class here. The third class passengers are over here. Then we take the first and second class passengers that are left this side. And if you're not greater than 16, that means you're less than or equal, you're less than 16. And out of that group, the bulk survived, 34 out of 36. So age here has a very significant bearing. Very specifically, if you're first and second class, you see the bulk there would survived. If you're greater than 16, so no, yes, you are greater than 16. And if you are yes second class, then 157 out of 249 died. But if you're not second class, third class, then 193 out of 315. So this small visualization actually tallies reasonably well with the tidyverse that we would have engaged with, and it's another metric or optic that we can consider the outcomes. Now we could put in more variables here and have more sophisticated analysis, and that's something that we could explore at another stage. But this is a very powerful technique, and is one recommended by Halvarian to econometricians who want to deal with bigger data sets. Next, we'll follow in line with Halvarian's code. We're going to load in party kit. In fact, I think I should be loading in. Okay, I'll load in party. There's two. Party kit is an updated version of party. So I'll install that again, and I'll install party. Halvarian installed, I think, party. I must have changed that to party kit. And we make it available then in the library. And our plan here is to use C3 conditional inference trees, and we'll run the same code again, and we will plot out our outcome. So we'll still run. Maybe I'll pause for a moment while that's executing. Okay, so that's installed, and it just took a little bit longer than anticipated. And then we'll run the C3, and okay, it's fine, it works. C3 is another powerful technique, and it's self-pruning, which is also good. And we can see a little bit the classifications that are taking place here. However, then when we come down here, we lose a lot of the richness. So this is a weakness of, but a rare weakness that I've observed in the Google collaboratory, and we can probably, if we use the same code in the native environment, we get a better result. So what I propose, just below I have some R code, and we can paste that directly into an RStudio or R, and we can compare the same outputs. So we'll just highlight, and copy. And basically, we don't need here to run copy. We don't need to explain every single detail because we've already done that. We'll just run in the native. So I've opened up in the RStudio environment, and I've already installed many of the packages. So we can just make, these are already available. I installed last night. And I can just put the pound sign in front and then very quickly execute the code here and make it available. Okay, so we'll make tidyverse available. The data is now available. We'll glimpse data. Fine, same as before, same output as before. Run the Logout model, R part plot. Titanic, the survived is converted into a factor. We'll call the new dataset titanic3 just to distinguish it from the older one. We'll run our model and then we'll plot. And you can see we've the same output here as before. And again, probably a superior visualization in the native R environment. Okay, so that's an advantage with using RStudio. And then likewise, make available library. And we'll run and we'll plot the C3. Okay, and let's take a look at that C3 again. This is what we might describe maybe a better visualization. Okay, so let's just pause while we update the packages. Okay, and this is the finished output that we get from our analysis, right? So this is the C3. How do we interpret the C3 here? Okay, so we can copy this image to clipboard and then copy plot and go into Word, and we can paste. And we probably can do better than that. Let's go export, copy clipboard, and we can just widen it a little bit. And thousand, and copy plot. So we'll put it 2500, update preview. That's a little bit clear. Let's copy plot. Let's go back into Word. We'll delete. We'll go layout. Orientation is probably landscape. And let's paste in our plot here of the C3, and we get some interesting details here. First of all, in terms of what's going on, we have the male, female, so the gender. If you're male and your P class is first class and you are less than 54, your chances of survival are about a little bit less, about 40%. But if you're more than 54, your chances declined. Okay, so age here is optimized in this algorithm, machine learning algorithm classifying of the different individuals. We see here there's a group of 151 who satisfy these criteria. Their chances of survival for males satisfying these criteria, a little bit less than 40%. However, if your age is greater than 54, your chances of survival fell dramatically. This tallies a bit with the tidyverse exploratory data analysis. What we don't see are those few who are over 80 or over, all three survived, right? So that's not maybe completely, we don't see it completely. Then if you're second class or third class and your age is less than 9, so if you're obviously a child and you have a small family, then your chances of survival are excellent. But note here, and there's 24 in this group who pertain out of the, if we add these, each of these values here, we get 1,309. And if you satisfy these conditions, you're less than 9 years old, you're less than or equal to 2 in the family, siblings or spouse, prospects of surviving good. But if the family size, siblings or spouse, is bigger, so this is not quite family size, but if you have more siblings and that exceeds 2, we're in a different type of scenario, and there were 16 in that case who didn't survive. Now we can imagine in terms of the Titanic who might have survived, it would have been maybe problematic to pick which child you were prioritizing to survive, so everybody went down. Okay, that may have been the anecdotage. Age, if you're greater than 9 and you're second and third class and you're male, things look pretty grim, right? If you're female and you're first and second class, overwhelmingly you survived. If you are third class, again, we have this classification, additional criteria. If the family size is small, your prospects are not too bad. It's 50-50, better than 50-50. But if the family size, again, this is not family size strictly speaking, it's sibling or spouse, but we might see it as a proxy to family size. If the family size was bigger, then your survival was less good. Now, only a small group here satisfied this criteria. But if you fall into that pigeonhole, your chances of surviving fade quite dramatically under such circumstances. So this classification problem is dealt with very effectively, and the visualization could be very useful. We can see how this type of algorithm could be useful in a business setting where you have many issues in terms of who do we target marketing at, the type of marketing, maybe in an election, can you identify cohorts in the population who could be quite sensitive to a particular type of advertising? And these algorithms then are a very fast way to pull out characterizations about your underlying data that could be useful then in terms of predicting outcomes. Okay, let's leave that there.